Hi, Dennis. It's great to see you.
Great to be seen, Teresa. Thanks so much for having me today.
I'm glad you're here. And today we're talking about PID tuning and process manufacturing, process control. So I know Control Station has built its business on being experts in process control and creating software that makes PID tuning easy. So talk to me about what role the PID plays in process manufacturing and also how advances in automation infrastructure have affected the tuning of PID controllers.
Right. So the PID controller essentially allows process manufacturers to regulate the means of production. And the PID or forms of it has been around for ages. The earliest example, some will point to ancient Greece, where a very simple form of PID was used to move enormous doors. But the most widely cited example of PID being truly used in an industrial application date back to the late 1700s. It was a centrifugal flyball governor, which allowed for the regulation of steam within an engine. That today remains a very common application of the PID. Clearly, back in those times, everything was analog, and the process of tuning a PID controller was little more than guesswork. That improved with the advent of trending tools. And as you and I sadly both know, trending tools were essentially a spool of paper against which a pen would be affixed, and the pen would jump up and down in response or to characterize how the process was behaving. And using that trend as a graphic of dynamic behavior, practitioners could then manually estimate values for the process gain, the process time constant, and the process dead time. With the advent of the digital age, however, right, with the widespread use of computers, software came on the scene, and the benefit of tuning software is that it allowed for a more consistent and a repeatable process by which practitioners could access data and formulate appropriate tuning parameters. The one fly in the ointment of these early software packages for tuning is that they lack the ability to handle real world applications. Real world process dynamics are highly dynamic. They're noisy, they're oscillatory. And it wasn't until 2008 when, in fact, Control Station introduced the non-steady state modeling innovation that allowed for the dynamic and accurate modeling of complex real-world process data.
That's interesting because users, practitioners talk about PID controller tuning software, as you mentioned, but you do talk about process modeling. From your perspective, what's the relationship between modeling and tuning?
I love the question because you're right. Here at Control Station, we emphasize the value of the model. Tuning is essentially the ability to refine a controller's responsiveness. Once you have a good model, it's easy to tune. That refinement, if you think of applications, different applications that are common in industrial settings, the surge tank is one such application where its dynamic behavior, its purpose rather, is to absorb the impact of an upstream disturbance so that the process remains calm downstream, right? And so a controller would be tuned very aggressively so that it could take and absorb that dynamic, right, and smooth it out. In contrast, a controller could be tuned very conservatively if, for instance, its application, its purpose was to maintain set point tracking, right? So we're just trying to make sure that within a modest band that the controller is tracking that set point. So that can be easily done through refinement of tuning, but the modeling, right? What your question was getting at, we view that as something separate, though related. And it's the ability of a model to accurately describe a process's dynamic behavior, which is the real magic. The model is going to have the ability to assess accurately how far, how fast, and with what delay a particular controller will respond to those normal everyday disturbances. Without that good model, the tuning parameters themselves are of little value. And fortunately, with increasing amounts of data, higher resolution data from the process, software is now equipped with better tools with which to formulate the model and to deliver those more refined tunings.
You referred to higher amounts of data, higher quality data. For tuning software to do the work of calculating a model and generating tuning parameters, I almost can say tuning parameters, users need to access process data. So what are the most common ways to access data, and how does the industry's growing concern for cybersecurity play into that?
So we're fortunate, right, that fewer and fewer practitioners are applying the what we would call poke and hope methods, right? Those manual methods where they simply input values, cross their fingers, and they're now able to use varying forms of software to provide a more reasoned and, again, repeatable approach to their tuning process while seeking to improve control. To that end, however, it's historical data that remains a tried and true resource for many practitioners. Most data is historized, right, and includes those fundamental elements required when tuning. That's information related to a set point, to a controller output, a process variable, and of course some timestamp by which you can evaluate changes. Finding the bump test that is stored in the historian, though, can present a challenge, right? Unless you know when the set point change was made, when the manual output adjustment was performed, you're essentially looking for a needle in a haystack, and that can be a challenge for those that employ historical data. But fortunately, there's little in terms of a cybersecurity concern, as historical data is typically stored off of the control network and on the business network. That's to be contrasted with what is increasingly the more common approach, which is the use of live data. Practitioners are able to tap into their PIDs with the live data by connecting to the control network. The key benefit of this is that it's live, it's instantaneous, it's easily found, but maybe the most important attribute is its high resolution. They can access this data quite commonly using OPC connections. In the realm of Rockwell automation, this could involve Factory Talk Links gateway, the OPC server interface that's there. But it does introduce concerns about cybersecurity, because now you are on the control network and you're interacting with it. So those are the two, the historical and the live are the primary methods. And they do introduce, one being a non-cyber concern, whereas the other does have raised concerns.
That makes sense. Now, if I'm understanding what you're saying, it seems like using historical data is the logical choice for accessing data and tuning a plant's PID control loops. But, everything has advantages and disadvantages. What are some of the drawbacks to that approach?
Yeah, I agree with that assessment. there are legitimate concerns over live data, and many choose to use historical data as a result, because they're not interacting with the control network. But while on the business network, historical data does indeed have some setbacks. Typically, it is within the IT department's domain to assign the compression and exception guidelines. And what that means is they are taking all of this vivid data that was once live and extracting key components as they compress it so that they can store it. And what is often lost within the historized data is key attributes which can help in the formulation or the calculation of that all-important process model. And from the viewpoint of a software manufacturer focused on PID control and tuning, right, that's a major drawback.
Okay, so going back to what you said earlier, tapping into live process data presents challenges too. So what roadblocks do users run into with that approach?
Well, here in the live data access realm, you're having practitioners with immediate access to a facilities control network, right? They're installing software, something that IT departments do not like, whether it's tuning software or any software. Having that is a concern that anyone in the IT realm would appreciate. And it's hard to blame IT staff. Some research I'd done leading up to today's session was that a cybersecurity firm called Sophos had reported that in the year 2021, 55% of manufacturers were hit with ransomware. And that was up 50% or thereabouts from the prior year, 2020. I don't have more current data, but that presents an alarming trend. So on the one hand, you have historical data which can present difficulties because it lacks the resolution that can be so helpful when tuning PIDs for effective, if not optimal control. But and on the other hand, you have live data which has that robust, unadulterated data, but it does open up process manufacturers to cybersecurity threats.
So it kind of sounds like you're saying users are darned if they do and darned if they don't when it comes to accessing data for controller tuning and optimization. So what's the answer to what seems like a riddle?
So a third option recently came onto the automation scene. Here at Control Station, we refer to it as live historical data. And not to be clever, right, but it's the ability to access live data immediately before it becomes historized. So more specifically, software can now access live data from Factory Talk Historian SE on a pre-exception, pre-compression basis, or post-exception basis. And our Loop Pro suite of tuning software is just one example of a tool that can do this. And it provides the ability to capture data via Factory Talk links by way of the Factory Talk live data interface. And since the point of access is within the confines of a production facility's business network, it evades that concern of being on the process network. And so by getting the live data as it's going into the historian, or rather just before that, it still is a very robust source of data with lots of elements that assure the most accurate model, which assures the most effective PID controller tuning parameters. And this is just one way that Rockwell Automation and its technology partners like Control Station that we're innovating and working together to address changes that are being faced by the process manufacturing community. And as the only Rockwell Automation partner that's singularly focused on PID control and plant-wide process optimization, this is something that we're closely monitoring and looking to find ways to innovate so that we can support our customers and those of Rockwell Automation collectively.
For our listeners, I want to point out that earlier this year, we published a white paper from Control Station called, I'm going to read it because it's a little long for me, Successfully Optimizing Regulatory Controllers Without Risking Data Security. So I've put a link to that white paper in the episode description, and it's a really good read. I encourage you to download it. So thank you, Dennis. This was really interesting, and it's probably a new way of looking at PID tuning for some of our listeners. And I appreciate you being here so they can learn more about this.
Thank you, Theresa. Great to see you.
You too. So as always, thank you for listening. I'm Theresa Houck with the Journal Magazine, and we'll chat again soon.